Welcome to the Q&A session 25 from the chapter of electric charges and fields. The topic is the calculation of electrical field due to an electric dipole. So this session is in continuation of the session number 24 in which we have studied about the electric dipole. So the question here is find the resultant electric field at a point due to an electric dipole which is 20 centimeter away from each charge of the dipole, and the magnitude of each charge of the electric dipole is equal to 100 microcoulomb, and the separation between the two charges of this electric dipole is equal to 10 centimeter. So let us consider here one dipole. Let us say these are the two charges. So one is a negative charge, so the magnitude of that is equal to 100 microcoulomb, and the other one is if it's a positive charge, because a dipole consists of two charges which are equal in magnitude but opposite in nature, and the separation between these two charges is equal to 10 centimeter. So this is the separation between the two charges, which is equal to 10 centimeter. Now we have to find the electric field, the resultant electric field at a point which is 20 centimeter away from each charge. So that point can either be here. In this case, that point can be here, or it can be somewhere here. So let us consider that this is the point P where I have to find the resultant electric field, which is 20 centimeter away from each charge. So this is 20 centimeter. And this distance will also be equal to 20 centimeter. So this is a negative charge, this is a positive charge. Let us say that this is the point P here. I am just taking this point as A and this point as B. So this is a negative charge here. So the electrical field due to this charge will be directed inwards. That is, electrical field at this point P due to this negative charge will be directed towards the charge, because a negative charge, the direction of the electrical field due to a negative charge is always directed inwards or towards the charge. So in this is a negative charge, so the direction of the electrical field at this point P will be directed inwards, that is in this direction, like this, as indicated by this arrow. Now this is a positive charge. Now in the case of a positive charge, the electrical field is directed outward or away from the charge. So this is a positive charge, so the electrical field due to this positive charge at this point P will be directed outward, and it will be in the direction as indicated by this arrow. Now let us consider that this is the electrical field E1 and this is E2. Now here the magnitude of both these two charges are the same, and the distance of both these charges from this point is also the same. So here E1 will be equal to E2, and let us consider that this is equal to E. We will find the value of E later on. Now we will be using the parallelogram law of vector addition in order to find the resultant electrical field at this point P. So this will be equal to the resultant value R is equal to this E1 square plus E2 square plus 2 times E1 E2 cos theta. Let us say this is the angle theta. So this will be equal to E1 square plus E2 square plus 2 times E1 E2 into cos theta, where theta is the angle between E1 and E2. So that is something, so I have taken that angle equal to theta here. Now here since E1 is equal to E2 and I have taken it as equal to E, so this R will be equal to under root of, this will be equal to 2E square plus 2E square cos theta. So important here is that we have to find the value of cos theta. So here if this angle is theta, then this angle will be equal to 180 minus theta. Now these two sides, that is AP is equal to BP. So this angle and this angle, that is angle ABP, ABP will be equal to angle BAP. Let us say this is angle is equal to x. I am taking this angle as x. So x plus 180 minus theta will be equal to 180. So x plus 180 minus theta. This is equal to 180. So from here I am getting 2x is equal to theta, or x will be equal to theta by 2. So this angle x is equal to theta by 2. So here, but we have to find the value of cos theta. So here some basic mathematics will be utilized in order to solve this question. So we know that cos 2 theta is equal to 2 cos square theta minus 1. So if here you can see here it is 2 theta, so here it is theta. So cos theta will be equal to 2 cos square theta by 2 minus 1. So we have to simply find the value of cos theta by 2. So यहाँ से क्या होगा? From here I will just, now I have drawn one perpendicular from P to this line AB. This is a perpendicular line. Now when I will draw this perpendicular to the line AB, this and this, that is, it will, this perpendicular will divide the line AB into two equal parts. So this part, let us say this is the point D. So DB will be equal to 5 centimeter, and similarly AD will be also equal to 5 centimeter. So from here we can see that cos theta by 2 will be equal to, cos theta is equal to base upon hypotenuse 5 upon 20. This is equal to 1 by 4. So simply we will substitute this value here. So 2e square plus 2 and this will be equal to 2e square in bracket 2 cos square theta by 2. So this is equal to, the cos square theta will be equal to 1 by 16. So 2 into 1 by 16 will be equal to 1 by 8. So 1 by 8 minus 1. So from here the value of the resultant can be found. We will be substituting the value of E later on. So from here I am getting 2e square plus, this is equal to minus 7 by 8. So here this will be equal to minus 7 by 8 e square. So the resultant R is equal to 16 minus 14, that is equal to 2e square upon 8. So R is equal to, this is equal to 1, will be equal to e square upon 4. Or we can simply say that R is equal to, that is the resultant is equal to E upon 2. So the intensity of the electrical field, the resultant value of the intensity of electrical field at this point P due to these two charges will be equal to E by 2, where E is the intensity of electrical field due to the individual charges. So simply I have to now find the value of E. So E, now here E1 is equal to E2 is equal to E, so E is equal to, that is equal to 1 by 4 pi epsilon naught. So that I will be taking here as K. Here I have considered that this dipole is existing in free space. So E is equal to K Q. Now the magnitude of the charge is 100 microcoulomb. So I will convert this into coulomb. That is equal to 10 to the power minus 6 coulomb upon R square. R is what? That is 20 centimeters. So in meters it will be equal to 1 by 5. So 1 by 5 whole square. Now K की value होती है, K is equal to 9 into 10 to the power 9 into, this is equal to 100 into 10 to the power minus 6 divided by 1 upon 25. Now this 25 will go in the numerator. So this will be equal to 225 into 10 to the power, this is equal to 9 minus 6 is equal to 3 and plus 2, 10 to the power 5 Newton per Coulomb. So the value of the resultant electrical field at this point P, this is equal to E by 2. So this is equal to 112.5 into 10 to the power 5 Newton per Coulomb, or this can further be written as 1.125 into 10 to the power 7 Newton per Coulomb. So thank you very much for joining this session. In the next in this session, the most important thing was the usage of the parallelogram law of vector addition, and the second important thing, or the second important point was that we have to find the value of cos theta. Now cos theta, for finding the value of cos theta, we have used the formula of cos 2 theta, which is equal to 2 cos square theta minus 1. This was the formula which we have used in order to find the value of cos theta. So these were the two important points with reference to this question. So in the next topic, I will be coming up with the with another type of a question from the session number 2. It's from the session number 24, in which we have already studied about the dipole moment and the torque which is exerted on an electric dipole when it is placed in an external electrical field. So thank you very much again. Have a nice day. Bye.